Settle in and let your breathing slow, because the desert is better understood at night. The sun has stepped away and the sand is holding on to its last soft warmth like a heating pad that forgot to turn off. You might think the desert is empty, but it is only quiet about being alive. Every plant out here is budgeting water, pinching pennies of moisture, and making very boring choices on purpose. Tonight, with the Sleepless Scientist keeping you company, you will drift through the strange botany of desert superblooms, seeds that sleep for years, leaves that hoard water, and flowers that wait for the right darkness. Nothing rushed, just slow survival and a landscape that saves its miracles for later. You arrive after sunset, when the heat has stopped performing. The air is cooler now, and it finally feels like it has manners. The sand underfoot is still warm, but only in a tired way. It is the leftover warmth of a day that tried too hard. You think you are entering emptiness, a blank map, a quiet place, a pause in life. But that is the desert's favorite lie, and you are very easy to fool. Out here, everything alive is simply speaking in whispers to save energy. Even the smell gives it away if you let it. Dry dust has a clean mineral bite, like crushed stone and old sun. There is faint sap in the air, a thin green suggestion, not a perfume. And sometimes, if a plant has been bruised by wind, you catch something sharp, like cucumber skin. You can hear it too if you listen wrong. Not music, not silence, but a soft mechanical world. A distant insect clicking, an owl cutting through air, a small scrape of something hiding. The desert is not dead, it is just efficient. And the plants, especially, are the masters of efficiency. Most of them look boring for a reason. Small leaves, pale colors, squat shapes, slow growth, no dramatic gestures. They are not trying to impress you. They are trying to not evaporate. A leaf in a wet forest can be extravagant. Wide and thin, like a solar panel that never worries about rent. A desert leaf has to be careful. Every square bit of surface is a place where water can leak away. So many desert plants shrink their leaves until they are barely leaves at all. Some turn them into needles, some into nothing you would recognize. And then they pretend it was an aesthetic choice. It was not. You walk slowly and your eyes adjust. The dark is not empty either. It is layered. The sky is deep and crowded with stars, and the land is a lower, softer darkness. A bush becomes visible only when it blocks the starlight behind it. And as you keep going, you start noticing patterns. Plants sit where water might pass, not where it is beautiful. They gather near shallow dips, near gravel fans, near the edges of dry washes. They live by gossip, the rumor of where rain used to run. The ground itself looks plain until it doesn't. Some patches have a faint crust, darker than the sand around it. It is not dirt being dirty. It is life being small. Microbes, lichens, and tiny filaments holding soil together like a quiet net. You could crush it with one careless step. Congratulations, you have destroyed a living skin that took years to grow. The desert will not scream about it. It will just remember. But tonight, you are careful. You are here to look at the desert's boring genius. And the first lesson is simple. Water is everything, and the desert has almost none. So plants do what you would do with a scarce paycheck. They store, they ration, they delay, and they accept inconvenience as a lifestyle. And one of their most successful strategies is to become a living canteen. A succulent is not a plant that found water. A succulent is a plant that decided to carry water inside itself, like a hoarder with jars. Thick leaves, swollen stems, tissues packed with stored moisture. No sloshing, no drama, just dense, patient hydration. If you cut into a succulent, it is not woody and dry. It is wet, pale, and firm, like a vegetable that refuses to admit it is a vegetable. Those cells are inflated on purpose. They are full of water and full of dissolved sugars and salts that help hold it. It is not a perfect solution, of course. A fat leaf is a tempting snack, and the desert is not known for mercy. So many succulents add armor, spines, bitter chemicals, tough skins, anything that discourages hungry mouths. And those skins matter a lot. Desert plants often wear a waxy coat called a cuticle. It is a thin layer, but it behaves like a lid on a pot. Water inside the plant tries to drift out as vapor, and the wax says no. Some plants go further and add hair. Yes, hair. Tiny plant hairs called trichomes, soft as dust. They trap a little layer of still air close to the surface. Still air is boring air, and boring air does not steal water quickly. Wind is an underrated predator out here. It is not hunting you with teeth. It is hunting you with evaporation. So spines and hairs do more than protect from animals. They also make shade, and they disrupt airflow. They turn a harsh breeze into a slow crawl right at the plant's skin. And when your entire life is a negotiation with dryness, slow is good. You pass a cactus, and you see the classic trick. No leaves, or almost none, because leaves are leaky. Instead, the cactus uses its green stem to do photosynthesis. The stem is the solar panel, the water tank, and the body, all in one. It is a blunt design, like a water bottle that learned to grow. And it has ribs like folds in fabric. Those ribs let it expand after rain and contract during drought. It is not only storing water, it is managing volume without tearing itself apart. Inside, cactus tissues can be arranged to keep water where it matters. Some parts act like sponges, others like plumbing. The whole thing is a compromise between being wet enough to live and dry enough to not rot. Because yes, even in the desert, too much water can kill you. That sounds unfair, but nature specializes in unfair. A desert plant is adapted to drought, not drowning. When rain finally comes, the soil can stay wet just long enough to invite fungi and bacteria. So the plant has to drink quickly, then return to caution. And drinking quickly is not only about roots, it is also about timing. During the day, the sun is a bully. Heat pulls moisture out of anything it touches, and plants, inconveniently, must open tiny pores in their leaves and stems to breathe. Those pores are called stomata, and they are a necessary problem. A plant needs carbon dioxide, but gas it turns into sugars, so it opens stomata to let carbon dioxide in. But when stomata open, water vapor escapes. It is like opening your front door to get a grocery delivery. and losing your heating bill through the same doorway. In a wet climate, that is manageable. In a desert, it is a crisis with good posture. So many desert plants cheat in a slow and clever way. They shift their schedule. They do the risky part at night. This is where the desert starts feeling like a place with its own clock. After sunset, the air cools and it holds water a little better. Evaporation slows down, wind often softens. The whole world becomes less thirsty. Some plants take advantage of that by using a special kind of photosynthesis. It is called crassulacean acid metabolism. That name is long and unpleasant, so plants shorten it to a lifestyle. You can call it CAM, like a quiet nickname whispered in the dark. Here is the trick, and it is surprisingly elegant. At night, the plant opens its stomata and takes in carbon dioxide. It stores that carbon dioxide in its tissues, locked up in acids. Then, during the day, it keeps the stomata mostly closed and uses the stored carbon dioxide to make sugars. It is like shopping at night when the store is empty, then cooking during the day with the pantry sealed. It does not eliminate water loss, but it lowers the cost. And in the desert, lowering the cost is the entire game. If you could hear a cactus breathe, it would be a nighttime sound. A faint opening, a careful intake, then a long, patient holding. Not romance, just chemistry trying not to die. And desert plants do this kind of trading constantly. They trade speed for safety. They trade growth for survival. They trade beauty for sturdiness. Humans tend to admire the rare dramatic moments, like a superbloom. But most of the desert's achievement is invisible. It is the daily refusal to waste water. It is the slow decision, repeated, to stay alive without showing off. Even color becomes a strategy. Many desert plants are pale gray-green or coated in a bluish film. That film can be wax or fine hairs or a powdery bloom. It reflects sunlight, reducing heat load like a cheap umbrella. Some plants tilt their leaves too, not in a friendly way, in a defensive way. They angle leaves to avoid the midday sun, exposing less surface to the worst light. A leaf can behave like a person turning sideways in a crowded hallway, making itself smaller to pass through danger. And if you keep walking, you start seeing that many plants are not standing alone. They cluster near rocks, under shrubs, beside little mounds. Borrowed shade is still shade. Shelter is a currency, and the desert loves shared budgets. A rock during the day is hot, but it is also a windbreak. At night, it releases warmth slowly and can reduce frost risk in colder deserts. A shrub can slow wind and create a cooler pocket underneath. And beneath that shrub, you might find seedlings hiding, growing in the shadow of something older. This is called nurse plant behavior, and it is one of the desert's quiet kindnesses. The older plant is not being generous on purpose. It is just existing, and its existence makes a small, safer world nearby. Life piggybacks on life, because starting from nothing is hard. But now, speaking of night, once the sun drops, the desert's routine changes even more, not only for temperature, but for water in the air. Night can bring dew. Not always, not everywhere, but often enough to matter. Dew is a small thing, And the desert is built on small things. When the ground cools after sunset, the air near it can cool too. Cool air holds less water vapor than warm air, so moisture in the air can condense onto surfaces, stones, soil, plant hairs, spines, just a thin film, sometimes barely visible, sometimes enough to feel on your fingertips. Certain plants are shaped to catch it. A rosette shape can funnel droplets toward the center. Fine hairs can collect moisture from fog or dew and guide it downward. Some spines can act like tiny combs, encouraging condensation and drip. It is not a glass of water. It is not even a sip. It is more like licking the last condensation off a cold can. But when you do it every night, for years, it becomes meaningful. And while the plant world is doing its quiet accounting, another schedule is unfolding. Flowers. You are used to flowers as daytime objects. Bright petals, bees, sunlight, cheerful postcards. But deserts often prefer the night shift. A few desert flowers open after dark. When heat is lower and water loss slows, they may be pale, white, or cream-colored because pale petals show up in moonlight. They often smell stronger at night, releasing perfume into cool air that carries it farther. Scent is a billboard when you cannot rely on color. And the customers are different. Moths, for example, are the night couriers of pollen. They drift in, guided by smell, hovering with a soft, nervous energy. Some have long tongues that reach deep into tubular flowers. The flower offers nectar, and the moth unintentionally picks up pollen like dust on a sleeve. This is not a friendship, by the way. It is a transaction with zero eye contact. The plant wants its genes moved to another plant. The moth wants sugar. Neither is thinking about beauty. Beauty is just what the transaction looks like from far away. Some desert flowers even time their opening to a narrow window. A single night, sometimes, or a few nights. They bloom quickly because blooming is expensive. A flower is not just decoration. It is a manufacturing project. Petals, nectar, scent chemicals, pollen, all built from the same limited resources. In a desert, you do not run a factory unless you have reason. So timing matters. If you bloom during a dry spell, you might attract no pollinators. If you bloom during a heat wave, you might lose too much water. If you bloom too early, you might miss the insect boom that comes after rain. And if you are a plant, you do not get to check the forecast. You get to gamble with your life savings based on signals baked into your cells. That brings us to the desert's most patient strategy, the one that makes Superblooms possible, the strategy of waiting. Because for many desert wildflowers, the adult plant is not the main form of life. The seed is. A seed is a small, hard promise. It is a plant folded up inside a capsule with a packed lunch. It is designed to survive the kind of boredom that would crush you. In a desert, years can pass without enough rain to support a wildflower. If a plant insisted on living above ground the whole time, it would fail. So it does the sensible thing. It does not show up. Instead, it stays in the soil seed bank, a hidden library of future plants, scattered beneath your feet. Some seeds are from last year. Some are from several years ago. Some can last much longer, depending on the species and the conditions. This is not sleep like your sleep. Your sleep is active, full of cycles and dreams and repairs. A seed's sleep is more like a paused file. Metabolism slowed to almost nothing, protected by a coat that resists water and damage. And that coat is often the point. Many desert seeds have hard seed coats that act like locked doors. Water cannot easily enter. Oxygen cannot easily enter. The embryo inside remains stable, waiting. So what opens the door? Sometimes it is abrasion, sand movement, grit, tiny impacts over time, scraping the coat thinner. Sometimes it is temperature swings, the daily expansion and contraction that stresses the shell. Sometimes it is the digestive system of an animal, acids and grinding that scarify the seed, making it permeable. Congratulations, you have been eaten, and somehow this is good news. The seed passes through, and now it can finally drink. But even when water can enter, many seeds still refuse to germinate. They demand proof. Some require a certain amount of rainfall, not just one teasing sprinkle. Some require the right temperature range, so they do not sprout during a brief winter warm spell and then freeze. Some respond to chemicals in smoke, which can indicate that a fire cleared competing vegetation. A seed is not naive. A seed is paranoid, and it has earned it. In deserts with unpredictable rain, a seed that germinates too easily will die too easily. So, natural selection favors caution. It favors seeds that wait for a real opportunity. And when the opportunity finally comes, the response can be fast. Rain falls. The soil darkens. The smell changes. If you have ever smelled rain on dry ground, that sharp, earthy scent, that is called petrichor. It is partly plant oils and partly molecules from soil microbes lifted into the air. To you, it smells refreshing. To a seed, it smells like an alarm clock. Water seeps down into the top layer of soil. It reaches the seeds, and the locked doors begin to open. The seed coat softens. Tiny pores allow water in, and the embryo swells. Inside, enzymes wake up and start breaking down stored food. Starches become sugars. Proteins become building blocks. Cells begin dividing again, like a factory turning the lights back on. The first root, the radical, pushes out. It is pale, delicate, and determined. It dives downward, chasing moisture before the sun can steal it back. Then the shoot rises, searching for light. If the soil stays moist long enough, the seedling becomes a plant. If the rain stops too soon, it becomes a lesson. This is why timing matters so much for Superblooms. It is not only how much rain falls, but when it falls. And a single storm that dumps water all at once can be less useful than a series of smaller rains. Because water that falls too fast can run off or sink too deep beyond the reach of small roots. The desert is a place where even rain can be inefficient. It arrives dramatically, and then it leaves without saying goodbye. But when the pattern is right, when the rain comes in the right rhythm, something unusual happens. Many seeds get the same signal at the same time, and the soil, which has been storing potential like a battery, finally discharges. The desert flips from pause to play. You do not see it immediately, not on the first night. At first, it is just damp ground and the smell of minerals turned dark. Then, you notice tiny green points scattered like pinpricks. Seedlings. They are not impressive yet. They are just little cotyledons, the first leaves, simple and functional. But there are so many of them, and they are all doing the same urgent work. They grow quickly because they have to. A desert annual does not have years to become a shrub. It has a short window of mild weather and wet soil, and then the oven turns back on. So the plant races through its life: germinate, grow, flower, set seed, die back. It is not tragic, it is the plan. And when enough species do this together, when enough seeds wake as a crowd, humans give it a dramatic name: a superbloom. That word makes it sound like the desert is being generous. It is not. It is simply cashing in a rare check. A superbloom is what happens when rainfall and timing line up across a wide area. Not just one hillside, but valleys, fans, flats, sometimes entire regions. The seed bank has been building year after year, adding more potential with every small bloom. Then, one season provides enough water and enough follow-up moisture to let a huge portion germinate and survive. And the effect is disorienting. A landscape you thought you understood becomes unfamiliar. The ground that was beige and stone-colored becomes tinted, then speckled, then carpeted. Color arrives in layers, not all at once. Some species are early. They sprout fast, flower fast, taking advantage of the first good conditions. Others come later, as days warm, as certain pollinators become more active, as soil moisture moves and changes. It can feel like a slow parade. First the small, low flowers, then taller stalks. First one color dominates, then another joins, then another. Yellow patches, purple smears, white clusters that catch moonlight, orange bursts that look almost artificial. And of course, it is beautiful. Even I will admit that. And I have watched stars die. But it is also brief. A superbloom is a party thrown by organisms on a strict budget. They can afford it only for a moment. And then the invoices arrive. Heat returns, wind returns. The soil dries from the top down. Flowers wilt, petals brown at the edges, and the plant's priorities shift. Because the point of the flower was never the flower. The point was the seed. Once pollination happens, once pollen grains reach the right place, the plant begins building the next generation. Ovaries swell into seed pods, tissues harden, energy moves away from petals and into embryos. The color you loved fades because it has already done its job. And yet, even as the bloom fades, the desert does something else. It calls in its workforce. Because a bloom is not just decoration, it is food. Nectar, pollen, tender plant tissues, seeds later on. And when food appears in a desert, animals notice. But that is a little farther down the road. For now, stay with the plants and their quiet mechanics, because there is one more night trick worth watching. Once the sun goes down and the air cools again, those stomata can open. CAM plants can take in carbon dioxide safely. Other plants, even without CAM, can reduce water loss simply because the air is gentler. Night is when the desert becomes temporarily negotiable. You stand still and imagine the invisible exchange. Carbon dioxide entering, water vapor leaving, a slow trade across a living membrane. A plant is not passive. It is constantly deciding, cell by cell, whether to spend water to gain sugar. If you want a simple picture, think of it like this. The plant is running a business where water is money and sunlight is opportunity. To profit, it has to open the doors. But open doors let thieves in, and the thief is the atmosphere. So it opens the doors when the thieves are slower. At night, and as your eyes keep adjusting, you realize the desert at night is not only cooler, it is busier in certain ways. You might hear a soft buzzing, not from bees, but from night insects. You might catch a pale flower glowing faintly, not with light, but with contrast. You might smell sweetness you did not notice earlier, a small thread of perfume leading to nectar. Plants do not move much, but they do communicate. They communicate with scent, with timing, with chemistry. They communicate with structure, with spines arranged just so, with petals shaped like landing pads. And all of it is built around one central problem: how to stay wet enough, long enough to reproduce. So the desert gets picky about how it spends water. And one of the biggest expenses is building anything tall. You picture plants competing the way they do in a forest, all elbows in height, racing toward light. Wrong setting. Out here, getting tall is like buying a sports car when you live on a drip irrigation budget. Height means more stem to maintain, more tissue exposed to sun, more distance for water to travel from roots to leaves, more chances for something to go wrong. And in the desert, something is always auditioning. So many desert plants stay low, and they spread out instead. They make themselves wide and modest, like they are trying not to be noticed. That shape is not only about hiding from wind, it is about living where the air is kinder. Close to the ground, there can be a thin boundary layer of slower air. Not calm exactly, just less enthusiastic about stealing moisture. A low plant can sit inside that thin layer and lose water more slowly. And low plants do something else. They share shade with themselves. A little mound of leaves can cast a shadow on its own stem. A rosette can shade the soil at its center, keeping the root zone cooler. A small plant can make a small microclimate. A private room in a public furnace? You walk past a scatter of shrubs that look spaced out on purpose? They are not being polite. They are avoiding competition. Each shrub is surrounded by a rough circle of emptiness, a halo where roots and water claims overlap. It is a quiet territorial map, drawn underground, and that underground part matters more than the above-ground show. Because in deserts, the sky is the problem, and the soil is the opportunity. Even when rain finally arrives, it rarely arrives gently. It comes like a brief argument, loud, sudden, and over too soon. The soil has to catch it before it runs away. So roots become engineers. Many desert plants build shallow, wide root systems, not deep tap roots, but a sprawling net near the surface. That is where the rain goes first, and that is where it disappears first. A shallow root system is like setting out buckets when a storm hits. You do not wait for water to seep deep into the ground. You grab it at the door. Some shrubs can extend fine roots quickly after rain. The plant senses moisture, and it invests in new root tips fast. Those tips are short-lived, like temporary workers hired for a short job. Then, when the soil dries, the plant lets many of those fine roots die back. It sounds wasteful, but it is economical. Why pay to maintain plumbing that is connected to an empty well? Other plants play the opposite game. They send one main root down and down. A taproot is a long gamble, a drill bit looking for hidden savings. If that root reaches deeper moisture, the plant can survive longer droughts. But it is not guaranteed. Sometimes the deep soil is as dry as the surface, just more politely. And even when a plant has a deep root, it may still keep shallow roots too, because desert rain is fickle and you do not bet everything on one kind of luck. This is how you start to understand the desert as a place of mixed strategies. Different plants are running different budgets. Some live fast and cheap. Some build infrastructure. Some just wait as seeds, like unopened mail. And speaking of waiting, you can feel how the desert makes time stretch. A forest changes quickly in your mind because you can see the growth. Leaves unfold, branches push outward, vines climb. In the desert, growth is often invisible until it is suddenly not. A plant can sit for months doing almost nothing you would call progress. Then, after a rain, it swells, opens, greens up, flowers, and retreats again. It is not lazy, it is responsive. A desert plant learns to pause without dying. That is one of its most impressive talents and one of the most humanly annoying. You want things to happen on your schedule. The desert does not care about your schedule. It cares about moisture, temperature, and the math of evaporation. And now, because you are here at night, you start noticing another kind of timing. The timing of scent. A night-blooming flower is often pale, but it is also fragrant in a specific way. Not the heavy perfume of a garden rose, more like a clean sweetness that seems too soft for this place. That sweetness is made of volatile compounds, small molecules that drift through air easily. The plant manufactures them on purpose and releases them when the wind is calmer. It is advertising. To you, it feels peaceful, a faint ribbon of smell in the dark. To a moth, it is a glowing sign. Moths do not see the world the way you do. Many rely on scent, and on contrast, and on subtle light. A pale flower can stand out against dark soil like a small moon. Some flowers also guide insects with patterns you cannot see well. Ultraviolet patterns can act like runway markings. To you, the petals are plain. To a bee, they are a map. And bees, of course, are the day shift. But before the day shift arrives, the desert runs its night crew. Moths, some beetles, sometimes bats. In certain deserts, visiting big flowers like living helicopters. A bat-pollinated flower is often large, pale, and sturdy. It may smell, not delicate, but musky and fermented. It is not trying to charm you. It is trying to be found by something that navigates by sound and scent. And while you are thinking about these night visitors, you realize something quietly strange. A superbloom does not only create a carpet of flowers, it creates a temporary city. All that nectar and pollen draws insects. Insects draw predators. Predators draw larger predators. The desert food web inflates, briefly, like a lung filling. It is one of the rare moments when the desert feels loud. But you are not there yet. Not fully. Right now, you are still in the plant's part of the story. The part where chemistry decides when to gamble. And that gamble begins with a seed deciding, with cold practicality, whether this rain is real. Some seeds respond to soil moisture measured over days, not conscious measurement, obviously just biochemical thresholds. A certain amount of water has to enter the seed coat. A certain level of hormones have to shift. A certain balance between abscisic acid and gibberellins has to change. Those names sound like spells, and they kind of are. Abscisic acid tends to keep seeds dormant. Gibberellins tend to promote germination. Inside the seed, those chemical signals are like bouncers at a door. One says, "No, not safe." The other says, "Open up. We are doing this." Rain changes the negotiation, but not all seeds in the soil respond the same way, even in the same species. And that is not a mistake. That is risk management. In a desert, it can be wise for only some seeds to germinate during a good rain. The others stay asleep, just in case the rain was a trick. This is called bet hedging, and it is exactly what it sounds like. The plant spreads risk across time. You can imagine it like this. If every seed wakes up in one year and that year turns bad, the entire generation fails. But if some seeds wait, the species keeps a backup plan. It is not hope. It is statistics. And those sleeping seeds can form what ecologists call a seed bank. Not a building, obviously, just a hidden collection of viable seeds in the soil. In some deserts, that seed bank can be incredibly dense. Thousands of seeds in a small patch. A whole invisible crowd pressed into dust, waiting for weather to stop being rude. The seed coat, again, is the main security system. It can be thick and waxy, resisting water entry. It can contain chemicals that inhibit germination until they are washed away. It can even require physical damage to become permeable. That physical damage is called scarification. Sometimes it happens from sand abrasion. Sometimes from passing through an animal's digestive tract. When an animal eats fruits or seeds, the seed may get transported and deposited elsewhere. It might land in a small pile of nutrient-rich waste, which is a polite way of saying a biological gift bag. Congratulations, you got carried across the desert inside a gut, and now you are in fertilizer. Even rodents play a role here. Many desert rodents collect seeds and cache them underground. They are making a pantry. They forget some of those caches. They fail to recover others. And that failure becomes plant distribution. The rodent thinks it is saving food. The plant thinks it hired a delivery service. The desert is full of relationships like that, accidental cooperation. Nobody needs to like each other. They just need to overlap in useful ways. And now, if you let your mind drift forward in time, you can feel what happens when many seeds across a wide area decide yes. The first green is subtle. Then it becomes a texture. Then it becomes a blanket. The soil changes color first, from pale dust to darker damp. Then the surface becomes dotted with small leaves. Then you start seeing buds. A bud is a promise with a tight grip. It is a flower folded up and hidden, holding back until it is sure. When the bud opens, petals unfold like paper in slow motion. Not elegant, exactly. More like urgency. disguised as grace. Because the plant is racing the calendar, the desert gives it a few weeks of tolerable conditions, and then the heat returns. The plant must finish reproduction before the moisture account hits zero, so it works fast. Some desert annuals can germinate, grow, and flower in a short span of time. They do not build long-lived wood. They do not invest in thick bark. They invest in speed. And when many species do this together, you get that human word again, superbloom, a mass flowering event driven by rainfall patterns, temperature windows, and the stored potential of the seed bank. But it is not one uniform blanket. It is a patchwork. Different soils favor different plants. Sandy flats might host one set of species. Gravelly slopes host another. Clay soils hold water differently. And that changes everything. Even a small change in slope can matter. Water runs downhill, so a shallow depression can grow a denser patch, while a nearby rise stays sparse. A superbloom is not the desert becoming uniformly generous. It is the desert revealing its hidden topography in color. And because each species has its own timing, the bloom comes in waves. Early bloomers often have small, quick flowers. Later bloomers may be taller or more showy. Once conditions have stabilized, you might see patches of yellow first, then purple, then white and orange. You might see one hillside ignite with color while another stays oddly quiet. The quiet hillside might not be dead. It might just have fewer seeds of those species. Or the soil might drain too quickly, or the timing of rainfall might have missed its threshold. This is why people chase superblooms and sometimes leave disappointed. They want a guarantee. The desert offers probabilities, and still, when the conditions align, the effect is startling. You stand in a place that looked empty in dry years, and now it looks decorated. Not delicately decorated, like the desert is overcompensating. It can feel surreal because you know the background story. You know this is not a permanent transformation. This is a temporary release of stored life. And the stored life will store itself again. As the bloom progresses, pollination becomes the central work. Pollen grains have to move from flower to flower, and not all flowers are equal in how they manage that. Some flowers are generalists. They offer nectar openly, and many insects can visit. Others are specialists, built for a certain pollinator body shape. A tubular flower with nectar deep inside favors visitors with long mouthparts. A flat, open flower favors many small insects. Some flowers even have mechanical tricks. There are flowers that deposit pollen on a specific body part of an insect, a precise smear on the head or the back, so that when the insect visits the next flower, the pollen hits the right spot. It is efficient and slightly creepy. A flower is basically a genetic device with marketing. And because deserts can be windy, some plants also rely on wind pollination. Not the showy flowers, usually. Those are insect-focused. Wind-pollinated plants often have small, less noticeable flowers and produce lots of pollen. That pollen is light and dry, built to fly. It can make the air feel dusty in a different way, a biological dust. But during a superbloom, it is usually insects that steal the scene. Bees become common, especially solitary bees that live in soil burrows. They emerge when flowers are available because their own timing is synced to bloom periods. A solitary bee does not live in a big hive like a honeybee. Many desert bees live alone, digging tunnels in sandy ground, making small chambers for eggs. They stock those chambers with pollen and nectar like packed lunches. Then seal them. The larvae feed, develop, and eventually emerge when conditions are right. Often, that means after rain. You can see the theme. Rain is not only a plant event, it is an ecosystem event. Beetles visit flowers too, and their style is less delicate. Beetles often chew. They blunder through petals, eating pollen, sometimes damaging the flower. This is called florivari, flower eating. It sounds like sabotage, but it can still result in pollination because beetles get covered in pollen as they feed. Flies also participate, especially in cooler conditions when bees are less active. Butterflies can visit during the day using vision to find bright patches, and moths keep working at night, guided by scent. So, the bloom becomes a schedule, day shift and night shift, handing off the work. And while the flowers are open, they are vulnerable. They lose water through petals too. They risk heat stress. They risk being eaten. So, some flowers are short-lived. They open in the morning and close by afternoon, or open for one night only. A single night flower is a dramatic thing for a plant on a budget. It is spending resources for a brief chance at reproduction. It does it because, in that brief window, the odds are best. And once pollination happens, the plant shifts from marketing to manufacturing. The ovary begins forming seeds. Petals become less important, and the plant lets them go. The landscape changes again, not from color to nothing, but from bloom to fruiting. Seed pods appear. Dry capsules harden. The plant becomes less soft, more mechanical. And now you start to see the desert preparing for the next quiet phase. Seeds have to disperse. Some are light and wind carried. Some have little hairs like parachutes catching air currents. Some have wings, thin, papery edges that let them glide a short distance. Others are heavier, and they fall close to the parent plant. That can be risky because competition is strongest near the parent. But it is also safe because the parent was in a place that worked. Some seeds hitch rides on animals. They have hooks or sticky surfaces clinging to fur and feathers. They travel until they get rubbed off. Some seeds are expelled mechanically. A dry pod can twist as it dries, building tension, then snapping open. Seeds can be thrown outward, a small ballistic event. It is not violent in a cinematic way. It is just physics in service of genetics. And when the seeds land, many will not germinate immediately. They will join the soil library. They will become part of the seed bank, waiting for the next alignment of rain and temperature. In this way, a superbloom is not only a display, it is an investment cycle. The desert spends stored water and stored seed potential to create a burst of life. Then it converts that burst into new stored potential. Then it goes quiet again. And when you think about it like that, the desert starts feeling less like emptiness and more like slow breathing. Long inhale, long exhale, long pause. But you should not romanticize it too much. The desert is still an accountant with a knife. Many seedlings die even in good years. A hot day arrives too early. A dry wind pulls moisture out. A rabbit finds a tender patch and eats it down to stubs. Herbivory is constant pressure. Desert herbivores have their own water problems, and fresh plants are both food and hydration. So when a bloom happens, it is like a buffet opening, and everything hungry shows up. Some plants protect themselves with chemicals, bitter compounds, toxic alkaloids, irritating latex. They are not inviting you to taste. Others rely on spines and hairs, or they grow low and tough, making themselves hard to grab. Or they accept being eaten because their main goal is to make seeds before they are noticed. That acceptance can be surprisingly effective. If you only need a few weeks to flower and set seed, you can tolerate damage late in the season. You have already done the important part. And this is where the desert's animals begin to matter more. A superbloom feeds insects, and insects feed lizards. Lizards feed snakes. Snakes feed birds and mammals, and sometimes other snakes, because nature loves redundancy. Birds also take seeds directly. Finches and sparrows can descend on seed-rich patches. Ants collect seeds too, carrying them back to nests like organized little thieves. Some ants are seed harvesters, and they can be major seed movers. They select certain seeds, transport them underground, and discard the husks. That can protect seeds from being eaten by others, or from fire, or from drying sunlight. Sometimes ants inadvertently plant seeds in safe microhabitats. Again, nobody is being kind. It is just useful overlap. And while all this above-ground movement happens, something more stable is continuing underneath. Soil in deserts is not just crushed rock. It is a layered living system, and it can be surprisingly complex. When rain arrives, microbes wake up too. Bacteria and fungi become active, breaking down organic matter. They release nutrients that plants can use, like nitrogen and phosphorus, in accessible forms. In dry times, many microbes enter dormant states. They survive as spores, or they slow their metabolism drastically. Then, rain reactivates them, and the soil becomes chemically busy. This is part of why rain smells the way it does. That scent is not only wet dust, it is microbial chemistry returning to life. And now, because the soil is wet for a while, roots can interact more actively with fungi. Some of the most important relationships for plants involve mycorrhizal fungi. Mycorrhiza means fungus root, and that is basically what it is. A partnership between fungal threads and plant roots. The fungus grows thin filaments called hyphae. They spread through soil far beyond the root surface. They can access water and nutrients in tiny pores that roots cannot reach. In exchange, the plant gives the fungus sugars. Photosynthesis becomes currency, and the fungus gets paid. This relationship can improve drought tolerance. It can help seedlings establish. It can help plants gather phosphorus, which often limits growth in dry soils. So when you look at a desert shrub, you are not only looking at a plant, you are looking at a plant, plus its fungal network, plus its microbial neighborhood. You are looking at a community with boundaries you cannot see. And the boundaries matter during superblooms because seedlings can be helped or hindered by what is already in the soil. Some shrubs create what ecologists call islands of fertility. Under a shrub, leaf litter collects, wind-blown organic matter gets trapped, animal droppings accumulate where animals shelter. So the soil beneath shrubs can become richer than open ground. It can hold more nutrients and sometimes more moisture because shade reduces evaporation. This is why you often find seedlings clustered near established plants, not because they love company, because the microhabitat is better. But there is a cost, too. Established plants also compete for water, so a seedling under a shrub is trading shade and nutrients for competition. Everything is trade, and there is another quiet player in desert soils: biological soil crust. You saw it earlier as darker patches, a thin skin. That crust can include cyanobacteria, lichens, mosses, and fungi. It binds soil particles together, reducing erosion. It can also influence water infiltration. Sometimes it helps water soak in gently. Sometimes it creates a slight barrier that changes runoff patterns. It stabilizes the ground, which matters because desert wind is relentless. Without crusts and plant roots, fine soil can blow away, leaving gravel behind. That process can reshape the surface, changing where plants can grow. So the desert is not static. It is slowly rearranged by wind and water, and life tries to keep up. During superblooms, crusts can be both helper and obstacle. Some seeds germinate best in small cracks, where water collects. Some cannot penetrate a strong crust easily, and humans, with their heavy feet and tires, can break that crust quickly. A few steps off trail in a popular superbloom area can leave scars that last years. Congratulations! You took a photo and your boot prints will outlive the flowers. The desert is patient, but it is not forgiving. And since you are walking through this in your mind, you can choose to be lighter. You can step around crust patches. You can imagine the ground as something alive, not just scenery. Now, the night keeps cooling. In many deserts, the temperature swing between day and night is large. Dry air does not hold heat well, and without clouds, heat radiates away into space. So the desert can be hot enough in the day to feel aggressive, then surprisingly cool at night. This swing affects plants too. Plant tissues expand and contract. Water viscosity changes. Enzyme activity changes with temperature. Some plants have proteins that help protect their cells during heat stress. Heat-shot proteins, for example, help keep other proteins from unfolding and clumping when temperatures rise. Because proteins are fussy, heat can make them lose their shape, and shape is function. When the day gets too hot, plants may close stomata to reduce water loss, but that also reduces carbon dioxide intake. Photosynthesis slows, growth pauses. You might think of a plant as always working, always growing. In the desert, plants often operate in pulses: rain pulse, growth pulse, flower pulse, seed pulse, then pause. It is a stop-start life, like a car in traffic, except the traffic is weather. And speaking of heat, you can start to feel why shade becomes such a valuable resource. Shade is not only about comfort. Shade can change the water budget dramatically. Under shade, the soil surface stays cooler. Cooler soil means slower evaporation. It means moisture stays available longer for roots. Shade can also protect seedlings from sunburn. Yes, plants can get sun damage too. Excess light can overwhelm the photosynthetic machinery, leading to oxidative stress. Plants have protective pigments and mechanisms, but in harsh sun, especially when water's stressed, damage can occur. So some seedlings establish better under the partial shade of shrubs or rocks. This is part of why nurse plant behavior matters. A rock can create a small shadow that shifts during the day. A plant tucked near the rock can experience lower peak temperatures. The rock can also collect dew or funnel small runoff. In some deserts, you see plants arranged in relation to stones, like they are using them deliberately, because they are. Even the orientation can matter. A north-facing slope in the northern hemisphere gets less direct sun. It can hold moisture longer. So you may find different plant communities on different sides of the same hill. The desert is a mosaic of microclimates. Tiny differences in sun, wind, and soil make different opportunities. And when a superbloom happens, it is those opportunities becoming visible. Now, you let your mind drift back to pollinators again, because the bloom's success depends on them. Pollination is the transfer of pollen from the male part of a flower to the female part. In many flowers, both parts exist in the same bloom, but timing and structure can still encourage cross-pollination. Cross-pollination increases genetic diversity. It gives offspring a better chance of handling future conditions. And future conditions in a desert are always rude surprises. So, flowers evolve ways to reduce self-pollination. Some mature male parts first, then female parts later. Some position parts so that an insect visiting tends to pick up pollen from one flower and deposit it on another. Some plants can self-pollinate if needed as a backup. It is not ideal, but it is better than producing no seeds. This again is risk management. And pollinators respond to bloom size. In a big bloom year, insects may reproduce more successfully. Their populations increase. That increase can carry forward into the next season, influencing how well future blooms get pollinated. So the desert has feedback loops across years, not just within one season. A superbloom is not an isolated event. It is connected to what happened before and what will happen after. Rainfall patterns build the seed bank over time. Pollinator populations respond to resources. Herbivore numbers shift with food availability. Even soil nutrients change. When plants grow and die, they add organic matter to soil. In a desert, decomposition can be slow, but pulses of moisture accelerate it, so a big bloom year can leave behind more litter. That litter can feed microbes. That microbial activity can change nutrient availability. And then, in later years, shrubs and perennials can benefit, or invasive plants can benefit, which is its own grim story. Because yes, deserts get invasive species too. Non-native grasses can establish, especially along roads or disturbed areas. They can change fire regimes by adding continuous fuel. A desert that historically burned rarely can begin burning more often. Many desert plants are not adapted to frequent fire, so invasives can transform the ecosystem. This matters for superblooms because the seed bank and the native plant community can be disrupted. A bloom can shift from diverse wildflowers to a dominance of one invasive species. It may still look green briefly, but the story underneath changes. And stories underneath are what deserts specialize in. Now, you keep walking through the mental landscape and the night feels steady again. The air has that dry clarity, the kind that makes distant objects feel close. You look down at your feet and you see a small plant with tiny leaves, not succulent, not spiny, just modest. You might think How does something like that survive? No thick water storage, no obvious armor. The answer is often, it does not survive for long. It survives for just long enough. These are annuals, plants that live one season. They avoid drought by not being present during drought. The adult plant is a temporary structure. The seed is the long-term organism. So when the bloom fades, the adult plants dry quickly. Stems become brittle, leaves curl and crisp. The plant becomes a skeleton of itself. But in that skeleton are seed pods, dry and sealed, waiting for wind or touch. A gust comes through and the plant shakes. Seeds rattle inside pods like tiny beads. Then the pod opens and seeds spill onto the soil. Some seeds get caught in small cracks. Some roll into depressions. Some are carried a short distance by wind. A few get eaten, a few get buried. Most will not do anything immediately. They will wait. And as you think about waiting, you can feel the desert's main rhythm again. Long periods of apparent stillness, interrupted by short bursts of frantic productivity. It is not peaceful because it is gentle. It is peaceful because it is sparse. A busy forest is loud with life competing. A desert is quieter because life is constrained, compressed into rare windows. And those windows are controlled by water and by temperature and by the behavior of air, which brings you naturally back down to the ground again, to the place where moisture is held or lost. Soil texture matters. Sand drains quickly, letting water slip downward and away. Clay holds water longer, but can become hard and cracked when dry. Silt can hold water too, but is easily eroded by wind. Many deserts have soils with high mineral content and low organic matter. Organic matter acts like a sponge, holding water and nutrients. Without it, the soil is less forgiving, but under shrubs, organic matter accumulates. Under crusts, soil can be stabilized. In washes, finer sediments can collect, creating different conditions, so the desert is a patchwork quilt of tiny habitats. And during a superbloom, you can see the quilt pattern. Flowers are not random. They are revealing where the soil holds water just a little longer. And now, speaking of water holding, it is time to look closer at the root zone, where plants and fungi and microbes negotiate every drop. Down here, the world smells different. Not floral, not airy, but metallic, damp, and faintly alive. You are standing above a zone that almost never gets applause because it is hidden. But this is where the desert's real negotiations happen. In the first few inches of soil, you might imagine roots like straws, politely sipping. Wrong. Roots are more like a moving border, expanding when there is water, retreating when there is not. They are not just organs, they are strategies. A desert rain is often a brief sheet of noise. Then it is gone, and the sun returns to work. So you do not build a single, elegant root. You build options. Wide, shallow roots to catch the first wet pulse, and sometimes deeper routes for later. In sandy soil, water behaves like a rumor. It travels fast, and it does not stay long. The top layer wets quickly, then drains and dries and forgets you. So a plant spreads a mesh of fine roots near the surface, ready for that short window. Those fine roots are fragile, and that is the point. They are cheap enough to lose. When the soil dries, the plant lets them die back, like shutting down seasonal plumbing. It sounds grim, but it saves energy. And energy is also water. If you could shrink down and stand at root scale, the soil would not look like dirt. It would look like a collapsed city of pores and tunnels. Some pores hold air, some hold water, and most hold disappointment. Water clings to soil particles in thin films. The tighter the pore, the harder it is to pull that film away. This is why clay holds water so tightly. It is not generosity, it is grip. A plant may be surrounded by water that is physically there and still not able to drink it easily. This is where root hairs matter. Root hairs are tiny extensions of root cells, fine as dust. They increase the surface area, pushing into pores like fingers into cracks. They help the plant reach water films that would otherwise stay stuck to mineral grains. And now you notice something. Roots do not work alone. Even in a desert, fungi are present, waiting like everyone else. When moisture arrives, fungal threads grow outward. Quick, thin, quiet. These threads are called hyphae, and they are the building blocks of a mycorrhizal partnership. Mycorrhiza, fungus plus root. It sounds like a spell, and it behaves like one. The fungus explores the soil for water and nutrients. The plant pays the fungus in sugar, made from sunlight above. You can picture it like a trade route. The plant has energy, but limited reach. The fungus has reach, but no photosynthesis. So they make a deal, and neither side pretends it is romance. The fungal threads can extend far beyond the root zone. They slip into pores too small for roots to enter. They access phosphorus and nitrogen, and they can help pull water toward the plant. In return, the fungus gets carbohydrates, sweet, portable fuel. And here is the part people often miss. This partnership can change a plant's personality. A seedling with helpful fungi may survive longer between wet days. A plant with the right fungal community may tolerate more heat stress. Even the timing of growth pulses can shift. But there is always a but. The plant has to afford the sugar payment. If the plant is already stressed, already starved for carbon intake, paying a fungus can become expensive. The desert is full of relationships that work until they do not. You step carefully and you imagine the soil around a shrub. Under the canopy, the ground is darker. There is litter, dry leaves, brittle stems, tiny fragments of last season. This is an island of fertility, not rich like a forest, but richer than bare ground. Wind drops its cargo here. Dust settles. Seeds lodge. Animals rest in shade and leave behind nutrients, because biology is never elegant. So the soil under shrubs often holds more organic matter. Organic matter acts like a sponge, holding water a little longer. It also feeds microbes, and microbes release nutrients as they wake and work. When rain falls after a long, dry stretch, microbes do something dramatic. They surge. They metabolize fast, releasing a burst of CO2 back into the air. Ecologists sometimes call this the birch effect, a pulse of microbial activity after rewetting. It is the soil exhaling. You do not hear it, but it is happening. Chemical energy moving, bonds breaking, nutrients shifting hands. A desert superbloom is not just flowers, it is also soil biology, waking up and spending. Now, speaking of spending, plants are not the only ones trying to grab water first. Microbes compete too. So do fungi. So do tiny soil animals, like nematodes and mites, stirring the film of moisture between grains. You might think the desert soil is sterile. Wrong again. It is just intermittent, like a town that only opens its shops during rare festivals. And there is another player you have already met, the living soil crust, cyanobacteria, lichens, mosses, all woven into a thin surface skin. When dry, it looks inert. When wet, it can become slick and dark, actively photosynthesizing. Cyanobacteria are old, older than your sense of importance. They helped oxygenate Earth's atmosphere over geological time. And here they are now, making a living on the surface of a desert, clinging to dust like it is prime real estate. The filaments of cyanobacteria release sticky substances. These glues bind soil particles together, making the surface more stable. Stability matters because wind is always trying to steal the fine grains, the nutrient-rich grains. When the fine particles blow away, the surface becomes rockier. It is called desert pavement, a layer of pebbles left behind like bones. It looks tough, and it is, but it is also a sign of loss. So crusts protect the desert from being sandblasted into something even harsher. They slow erosion. They can also influence how rain infiltrates, guiding water into cracks and channels. And yes, they are fragile. A footprint can crush decades of slow growth. A tire track can cut a scar that changes runoff patterns and seedling success. Congratulations. You invented a tiny canyon with your impatience. The desert will incorporate your mistake into its next few years. Now, your mind drifts forward again, because the outline of this story is not just underground. It is also above ground, where the heat waits like a rude landlord. Heat in a desert is not just hot air. It is sunlight pouring down without much atmospheric softness. It is soil surfaces heating until they are hostile to skin, roots, and small lives. Plants cannot walk to shade, so they build it, or they borrow it, or they shape themselves to reduce damage. You see leaves that tilt away from noon. This is not laziness, it is geometry. By angling the leaf, the plant reduces direct radiation during the hottest hours. It still gets light in the morning and afternoon, when the sun is less brutal. Some plants fold their leaves, some roll them inward, turning a broad surface into a narrow tube. Inside that tube, the air is more humid, and the stomata lose less water. It is like pulling a blanket over your mouth in winter, breathing into your own little climate. Other plants go pale. A gray-green leaf reflects more light than a dark one. Sometimes the paleness comes from wax, sometimes from dense hairs. Those hairs scatter sunlight, and they slow wind right at the surface. The boundary layer matters. A thin layer of still air can protect against rapid evaporation. It is a microscopic shield, and it can mean the difference between functioning cells and crispy failure. If you touch a hairy desert plant, it can feel soft. That softness is deceptive. Underneath, tissues may be tough, resinous, bitter. The plant is offering texture, not comfort. And then there are spines, not just defense, but shade. A spine casts a shadow. A cluster of spines casts many shadows. The shadows move across the cactus surface as the sun moves like a slow, protective clock. A cactus is basically a water tank with a heat management problem. Its ribs create self-shading. Its wax reduces loss. Its stomata open mostly at night for the plants using CAM photosynthesis. It is a system built for scarcity and for patience. Now, sometimes patience looks like doing almost nothing. After a heat wave, many desert plants do not push through heroically. They pause. Photosynthesis slows. Growth stops. Leaves may droop or close, not because they are dramatic, but because they are conserving. A plant can tolerate dehydration to a point. Cells lose water, but maintain structure, using sugars and protective proteins. Membranes adjust, becoming less leaky. Some plants accumulate compounds that stabilize proteins, like proline and certain sugars. You do not need to memorize the names. Just remember the feeling. A plant bracing itself internally, like clenching your jaw during bad news. And then there is the trick of location. Many plants grow in the shelter of rocks or beside shrubs. You already saw this nurse plant behavior, but in heat, it becomes even more obvious. In full sun, soil can get hot enough to damage fine roots. In shade, the soil stays cooler and moisture lasts longer. Seedlings are especially vulnerable. Their root systems are small, their tissues tender, their margins thin. So a rock becomes more than a rock. It becomes a thermal buffer. It shades for part of the day. It releases heat at night. It can collect dew on its surface and drip it toward the base. Even the side of the rock matters. North-facing shade in the northern hemisphere can be a sanctuary. South-facing edges can be punishing. So you can sometimes find plants clustered on one side, like they chose it, because they did. In the slow way plants choose things, seeds that land in better microhabitats have better odds. Over years, that becomes a pattern, and patterns are what you are really watching, not individual miracles. Now, let the story widen, because deserts do not have a single season. They have calendars that depend on where you are standing on Earth. Some deserts get winter rain. Cooler storms roll in from oceans and drop moisture during the colder months. Plants in those deserts often do their main growth in winter and spring, when evaporation is lower. Other deserts get summer monsoons. Moist air moves in, thunderstorms build, and rain arrives with lightning and sudden drama. Plants there may green up in late summer and flower in patterns tied to those storms. And some deserts get a little of both or get neither for long stretches. The desert does not promise consistency. It offers you variability and calls it character. This matters for superblooms. A superbloom is not just a lot of rain. It is rain arriving at the right time, in the right sequence, with temperatures that allow seedlings to survive. If rain comes too early, seedlings may sprout, then freeze. If rain comes too late, seedlings may sprout, then cook. If rain comes as one huge downpour, much of it may run off, especially on hard-packed ground. But if rain comes in spaced events, wetting then re-wetting, then a follow-up, the soil stays usable longer. Seeds germinate in waves. Different species hit their thresholds at different moments. So the bloom becomes layered, and the layers can change year to year. Some years favor shrubs and perennials. They use the moisture to grow leaves, extend roots, store resources. Other years favor annual wildflowers. They use the moisture to sprint through life and fill the seed bank. This switching is not a conscious decision. It is an outcome of weather meeting life history strategies. A long drought can reduce the number of viable seeds near the surface. Heat and time can degrade them. Animals eat them. Fungi sometimes attack them when conditions briefly allow. Then a rare wet stretch can rebuild the seed bank. One good bloom year produces seeds. Another decent year adds more. Then, when the perfect alignment happens, you get the big show. And humans, of course, notice the big show and arrive in great numbers with cameras and snacks and a talent for standing exactly where they should not. You can picture it. A hillside of color, a narrow trail, and people stepping off to get a better angle. Each step crushes seedlings you cannot see. Each step breaks crust that took years to form. Each step compacts soil, reducing infiltration next time it rains. The desert is not angry about this. The desert does not do anger. It does consequences. In heavily visited superbloom areas, the damage can linger. Less crust means more erosion. More erosion means seeds wash away. Compaction means water runs off instead of soaking in. The next bloom can be weaker, not because the desert is moody, but because the physical conditions changed. Even the introduction of invasive plants can be tied to disturbance. Seeds, hitch, rides on tires, shoes, pets. Road edges become corridors for non-native species. Invasive grasses are especially good at exploiting brief moisture. They can grow fast, fill gaps, and then dry into continuous fuel. This can increase fire frequency, and frequent fire can be devastating in many deserts. Some desert shrubs and cacti do not recover quickly from fire. Their tissues are not built to resprout after repeated burns. So, a shift in fire regime can reshape the landscape, turning a shrub desert into a grassier system, or into a more eroded one. It can still look like nature, but it is a different set of rules. Now, while all that long-term change hums in the background, you stay closer to the ground again. Because the desert's daily routine still matters, and heat is only one extreme. Many deserts also get cold nights. Without clouds, heat radiates away into space. Temperatures can drop sharply, sometimes to freezing. So plants face a strange combination: intense daytime heat and nighttime cold. Cells have to handle both. Membranes must stay functional across swings. Water inside tissues must not freeze in ways that rupture cells. Some plants tolerate freezing by allowing ice to form outside cells, in spaces between them. That draws water out of cells, dehydrating them, which sounds awful and is awful, but can prevent lethal ice crystals inside the cell. Other plants avoid freezing damage by staying close to warmer microhabitats near rocks or under shrubs. Again, microclimate matters, and now your attention shifts to time again, not hours, but years. Rain is not random exactly. It is patterned by climate cycles, ocean temperatures, atmospheric circulation, storm tracks. In some regions, years of drought can be followed by wetter years tied to large-scale patterns like El Niño. Warmer ocean surface temperatures can influence where storms travel. That can mean more winter rain in certain deserts, which can set up strong bloom seasons. But it is never guaranteed. The desert does not sign contracts. And climate change complicates this further. Warmer temperatures increase evaporation demand. Even if rainfall stays similar, hotter air can pull more moisture from soil and plants. In some places, rain may come in fewer, more intense events, increasing runoff rather than infiltration. In other places, the timing of seasons may shift. Heat waves may arrive earlier in spring. For a desert annual trying to sprint from germination to seed, set a week can matter. A few days of extreme heat can kill flowers, reduce seed production, or shorten the whole season. So the future map of superblooms may change in frequency, in location, in species composition. This is why ecologists monitor blooms, not just because they are pretty, but because they are indicators. They reflect rainfall patterns, soil conditions, and ecosystem health. Now, you return to the living plants again, because the story is still tactile. You imagine walking through a bloom year. As it begins to fade, petals fall, flowers dry. The color drains from the landscape like someone turning down saturation. But the plants are not done. They are making seeds, and seeds take resources. During seed development, the plant reallocates sugars and nutrients. Leaves may yellow as nitrogen is moved from leaf proteins into developing embryos. The plant is dismantling itself to build the next generation. You can see seed pods hardening. Some become papery capsules. Some become spiny burrs. Some become tiny nutlets that fall with a soft tick. And because the desert is windy, wind plays a big role now. Dry stalks rattle, pods shake. Seeds release in small bursts, not all at once. Some plants even tumble. A whole dry plant breaks loose and rolls, dropping seeds along the way. It is a seed dispersal strategy and also a reminder that tumbleweeds are not always native. But the concept is old. For seeds that are small and light, a short gust can be enough. They lift, drift, and settle in new pockets. Often they lodge in cracks beside stones, at the base of shrubs, places where water might collect later. For heavier seeds, animals become the transport. Ants carry seeds to nests. Rodents cache them. Birds pick them up and drop them. Some seeds have little fatty attachments called elaiosomes. They are like bribery snacks for ants. The ant carries the seed home for the fatty reward, then discards the seed in a safe underground spot. It is called myrmecochory, ant dispersal. Again, the name sounds like a spell, and the effect is simple. A plant outsourcing delivery to tiny workers who do not know they are employed. And then, once seeds are placed, the desert returns to its quieter palette. The plants above ground become brittle. They break down slowly. Decomposition is limited by moisture, so dead plant matter can persist. But when rare moisture returns, microbes and fungi break it down in pulses. Nutrients are released. So even dead stems are not wasted, they are future fertility slowly distributed. You start to see the desert's efficiency again. Nothing stays dramatic for long. Everything converts. Now, there is still one part of the story we have not fully inhabited. Because you have watched plants and soil and rain and time, but the desert also runs on movement, on the quiet shift work of pollinators, returning again and again, year after year. In a bloom year, insects emerge in synchrony. Some have been waiting underground as pupae or larvae. Others arrive from nearby habitats, and you can feel the difference between day shift and night shift. During the day, bees are the most famous workers. But desert bees are often not honeybees. They are native solitary bees, small, fast, purposeful. A solitary bee does not have a hive full of sisters. She digs a burrow in sandy soil, makes chambers, and stocks them with pollen. Each chamber is a nursery with a packed lunch. She is not making honey for a future winter. She is making survival packets for offspring, sealed underground. The timing is tight. The bee needs flowers to supply pollen and nectar. The flowers need bees to move pollen. So both are often tuned to rain events, like two clocks set by the same storm. Some desert bees are specialists, visiting only certain plant species. If those plants do not bloom, the bee struggles. If the bee does not emerge, the plant struggles. It is a relationship built on timing, which is a risky foundation in an unpredictable climate. Other insects are less picky. Flies visit flowers, especially when temperatures are cooler. Beetles blunder through, chewing pollen and petals. Butterflies sip nectar, guided by bright color patches. And then, when night returns, the moths take over. A night-blooming flower often uses pale petals and strong scent. Scent travels farther at night because the air is calmer and cooler. The flower is advertising into darkness. Moths follow scent plumes like invisible roads. They hover, probe with long mouth parts, and pick up pollen on faces and bodies. Some flowers are shaped to fit a moth's hovering posture, offering nectar at just the right depth. There are also beetles active at night and sometimes bats, depending on the desert. Bat-pollinated flowers are often large and tough with a musky odor. They open wide, offering abundant nectar because a bat's metabolism is expensive. A bat burns energy quickly in flight, so it needs a rich reward. The flower pays in sugar and gets pollen transport over long distances. To you, a bat's wings might feel spooky. To a cactus flower, a bat is a delivery truck that works nights, and you can see how a superbloom becomes an ecological pulse. Insects rise in number. Then, predators respond. Lizards become more active, hunting insects among flowers. Birds forage on insects and seeds. Small mammals feed on fresh plants, and later on, seeds. Even spiders benefit, building webs near flower clusters where insects pass. The bloom creates traffic, and where there is traffic, there are ambushes. The desert is not celebrating, it is exploiting an opportunity. Now, speaking of opportunity, you are about to notice something subtle about flowers themselves. They are not just colorful cups of nectar. They are structured devices for controlling behavior. Some flowers have nectar guides, patterns visible in ultraviolet, directing bees to the center. Some have landing platforms, shaped petals that support certain insect weights. Some hide nectar deep, filtering visitors by tongue length. This is not hospitality. It is selective access. A flower benefits when a visitor contacts the right reproductive structures. So, it shapes its opening, places its anthers, positions its stigma. It puts the pollen where it will stick and where it will be delivered next. Sometimes, pollen is presented in bursts. Sometimes, the flower releases scent at specific times. Sometimes, a flower even warms itself slightly, generating heat through metabolism to attract insects seeking warmth at night. Thermogenesis, heat making. It happens in some plants, more famously in certain tropical flowers, but the concept of flowers manipulating microclimate is universal. And all of this is happening while the desert still threatens dehydration. A flower loses water through its tissues. Petals are thin. They can wilt quickly. So many desert flowers are short-lived, opening during optimal windows. Some open in the morning and close by midday heat. Some open only after sunset and close at dawn. Some last a single night. This is why bloom timing feels so dramatic. You are watching organisms spend stored resources in fast, decisive bursts, then retreat. Now, as the season shifts, the insects also shift. When flowers fade, nectar disappears. Some insects move on. Some die after reproduction, their own life cycle complete. The desert food web contracts again. It is not tragic, it is seasonal, but it does mean that superblooms are not just visual events, they are demographic events. A good bloom year can produce a generation of bees. It can produce more lizards. It can support more nesting birds. Then, in subsequent dry years, those populations may crash back down. The desert is a system built on pulses, and pulses create booms and busts. If you are the kind of creature that wants stability, the desert is not your friend. But many desert species are adapted to this rhythm. They have flexible reproduction, dormancy stages, and fast development. Even the plants, again, rely on dormancy as seeds. And now, as you think about seeds returning to the soil, you start to sense the long, quiet interval coming back. The period between spectacles. But before you drift too far forward, there is one more detail worth holding, because not all desert plants are annuals. Perennials, shrubs, cacti, long-lived herbs, they persist through years. They store resources in woody tissues, in thick stems, in deep roots. When a wet year comes, perennials may flower more, they may produce more leaves, they may grow new branches. They may store extra carbohydrates, preparing for future drought. So a superbloom year is not just annuals sprinting, it is also perennials quietly recharging. A shrub might produce a flush of new growth. That growth shades soil, traps litter, and creates islands of fertility for later. So a wet year can have effects that last beyond the visible bloom. It can change soil nutrient pockets. It can influence seedling establishment for shrubs and trees. It can alter competition because more growth means more shade and more root activity. Over years, sequences of wet and dry shape the community. A run of dry years might favor hardy shrubs that can persist. A run of wet years might allow more annual diversity and more recruitment of perennials. So, the desert's plant community is not fixed. It is a moving average of weather and survival. Now, let your attention move back to the sensory world again, because the desert teaches through texture. In a dry year, the land looks open, sparse, almost blank. In a bloom year, you see a thin green fuzz first, then a stippling of buds, then color. And when it fades, the color does not vanish instantly. It turns into tan stalks and seed heads. The ground becomes a litter of dry matter. That dry matter becomes shade at soil level. Even dead stems can slow wind near the surface. They trap blowing seeds. They catch drifting dust. So even after the bloom, the remains keep doing work. The desert does not waste structure. If rain comes again, even a small rain, the litter can help hold moisture longer near the surface. It can improve germination success for some species. It can also shelter insects and small animals. So the fade is not an end. It is a conversion from bright petals into subtle engineering. And now, as the weeks pass in your mind, you can picture the seed bank thickening again. Some seeds will germinate quickly if moisture returns. Others will remain dormant due to hard coats or chemical inhibitors. Some require temperature cycling. Some require light exposure after being moved near the surface. There are seeds that germinate better after being buried for a while. Others need to be near the surface to sense temperature swings. The seed bank is not uniform. It is layered by depth and disturbance. A seed buried too deep may never emerge because the seedling cannot reach light. A seed too exposed may be eaten or desiccated. So the ideal position is a narrow band, shallow enough to emerge, protected enough to persist. That is why cracks matter. That is why small depressions matter. That is why the base of shrubs matters, and that is why your footsteps matter too, because disturbance can both harm and create. A footprint can crush crust, which is damage, but it can also create a small depression that catches water and seeds. The desert is not sentimental. It will use whatever structure exists, but repeated disturbance tends to simplify, compact, and erode, which usually reduces diversity. Now, since you are still here with the desert's slow calendar, you can begin to feel the larger timescales again. Some deserts are expanding in certain regions due to shifting climate patterns and land use. Overgrazing can reduce plant cover, increasing erosion. Irrigation can change soil salinity, altering plant communities. Roads and development fragment habitats, changing water flow and invasion pathways. Even atmospheric nitrogen deposition from distant pollution can fertilize some desert systems. That can favor fast-growing invasive grasses and weeds. It can shift competition away from slow, stress-tolerant natives. So the desert superbloom you admire can be altered by forces far away. A storm track over an ocean, a fertilizer plume from a city, a boot print on a crust. And still, the desert persists, not as a static scene, but as a dynamic system that keeps recalculating. Now, you turn your attention back to a single plant again, because the small scale is where the calm hides. Imagine you are a young desert annual, a seedling that germinated after a good rain. You are small, close to the ground, where air is slightly calmer. Your first leaves are simple, not yet the adult shape. During the day, you face intense light. Your stomata open carefully, balancing carbon intake with water loss. If you have the C3 pathway, the common photosynthesis type, you are more vulnerable to water loss during the day. Some desert annuals do not use CAM because they are built to live during cooler months. They can afford daytime gas exchange when temperatures are mild. So, winter annuals in a desert can behave differently than summer-adapted succulents. This is why desert botany is never one story. It is many stories sharing a landscape. As a seedling, you grow fast, pushing a root down and out. Your root finds moisture pockets, maybe near a stone. If you are lucky, you have mycorrhizal fungi assisting, extending your reach. You build buds, then you flower. Your flower opens at the time most likely to get a visit, maybe morning for bees, maybe evening for moths. You release scent, you display color, you offer nectar. Then, if the pollen arrives, you set seed. And now the sun strengthens again, and the soil dries. You do not fight it for long. You shift your energy toward finishing seed development. Your leaves may yellow, your tissues dry, you become brittle. You become a structure for dispersal. Then wind comes and shakes you. Seeds fall into the soil, into cracks and shade pockets. And you, the adult plant, become debris, then nutrients. Your life above ground was brief. Your real life continues as seeds, dormant and distributed. That is the desert's rhythm, a long, quiet baseline, interrupted by short, efficient surges. And as you continue walking through this in your mind, the landscape begins to look like itself again, less colorful, more mineral, more restrained. It is tempting to call that emptiness, but you already know better. Under your feet, the seed bank waits. In the soil, microbes rest. On the surface, crust organisms dry into dormancy. Everything is paused, not gone. The desert's calm is not absence. It is stored potential. And because it is stored, it can be spent again, but only when the desert gets paid in rain. Until then, you are left with a landscape that looks simple and feels old and is quietly busy doing nothing. You walk through what people call the off-season, when the color has drained away. The ground is mostly tan, gray, and that blunt, honest shade of rock. Dry stalks still stand in places, thin and rattling like abandoned scaffolding. If you brush one by accident, it snaps with a sound like dry paper. That sound is not sad, it is practical. A dead stem is a future windbreak and a future seed trap. Even failure gets recycled into function out here. And while you stand there, looking at a desert that seems to have shut down, you notice the smallest movement, a line of ants stitching the surface with patient intent. They are not celebrating the bloom, they are cleaning up after it. If you follow them with your eyes, you see what they are carrying. A seed small enough to loosen a fingertip crease, dragged like a trophy. To you, it is nothing. To an ant colony, it is calories with a shell. Some of those seeds have that oily bribe attached, an elaiosome. The ant wants the fat, not the plant. So the ant carries the seed into the nest, eats the reward, and discards the rest. Congratulations, you just got planted by an insect that thinks you are trash. The discarded seed ends up underground, tucked into damper, safer soil. It is hidden from birds, hidden from sun, and sometimes hidden from fire. This is how the desert does long-term planning. Not with intention, with accidents that persist. Above ground, wind keeps doing its slow vandalism. Dust slides along the surface in thin sheets you barely notice. It collects behind pebbles, behind dead stems, at the base of shrubs. And when dust collects, so do nutrients. A desert is not only water limited, it is often nutrient limited too. Nitrogen, especially, can be scarce in dry soils because biology runs slowly without moisture. So a lot of desert fertility arrives in strange ways. A bird droppings under a perch, a dead insect dissolving into minerals, a dust storm carrying tiny particles from far away, like unwanted mail. Some of the nitrogen arrives through organisms that can fix it. Certain bacteria, including some living in soil crusts, can take nitrogen gas from the air and turn it into usable forms. It is chemistry so useful, it feels like theft. And it is slow work. It is not a lush rainforest factory. It is a small, stubborn budget, balanced one molecule at a time. Now your eyes lift, and you remember the plants that do not disappear between blooms. The perennials, the shrubs that look unchanged year to year. Until you pay attention, they carry the memory of wet years inside their tissues. A creosote bush, for example, can look like the same dusty green shape for decades, but it is constantly adjusting its leaf wax, its stomata behavior, its root activity. After rain, it may push out fresh leaves, glossy and scented, then harden them for drought. Creosote leaves carry resins that smell sharp when warmed or crushed. That smell is not just for you. It discourages some herbivores, and it slows water loss, and it helps the leaf survive sun. Perennial desert plants often invest in toughness because they have to stay present. Annuals can solve drought by leaving, by becoming seeds. Perennials solve drought by enduring, by turning their bodies into storage and armor. And endurance has side effects. A perennial shrub shades soil every day, even in dry years. It traps litter. It creates an island of fertility, a small dark patch in a bright world. Those islands shape where the next bloom happens, not all at once, not dramatically, but as a pattern. Seedlings establish in the shade, then some survive, then some become part of the shrub community. Time out here moves like that, in increments too small to film, but too large to ignore. You also start noticing the way a desert stores water in places you would not expect. In the shadowed side of a washbank where soil stays cooler. In the packed gravel of an alluvial fan where water infiltrates unevenly. In the deeper layers beneath a shrub where organic matter holds moisture like a sponge that refuses to dry. This is why the desert can look uniform and behave like a mosaic. 2 steps apart, the soil can have different texture, different microbes, different seed density. The surface is plain, but the rules change constantly under it. And this brings you to the simplest, most unsentimental truth of superblooms. They do not happen because the desert wants to be beautiful. They happen because the desert is good at saving, and rain is a rare permission slip. So when the permission does not arrive, the system does not collapse in despair. It just waits again. Plants close their stomata earlier in the day. Growth pauses. Leaves may drop, reducing surface area, cutting losses. Some shrubs can even shed leaves during severe drought, going partially dormant. They look dead to you, and then they rebound with the next decent rain. You call it resilience. The plant calls it not spending money it does not have. Now, there is a human urge to interpret this as wisdom, to see patience as a moral virtue. But out here, patience is just what happens when physics sets the pace. Evaporation is relentless. Sunlight is constant. The air is usually dry enough to steal water from anything that opens itself. So life adapts by reducing exposure, reducing activity, and doing its most important work fast, which is why a superbloom can feel so shocking. It is the desert briefly acting like somewhere else. And when that happens, you can almost watch the ecosystem breathe harder. Insects appear in higher numbers because larvae survived in damp soil. Solitary bees emerge and begin their urgent schedule, visiting flowers like tiny machines. Lizards become more visible because there is more prey moving. Then, just as quietly, the contraction begins. Flowers close, nectar dries up, insect numbers drop because the food pulse ends. Predators follow the curve downward with a lag. A superbloom is a pulse that propagates through a food web. It is not only color, it is population dynamics, written in petals. And because you are here at night, you notice one last detail most people miss. Some of the bloom's work continues after sunset, even late in the season, a pale flower that opens for one final night. A moth that still finds it, guided by scent in cool air. The transaction repeats, small and stubborn. Nectar for pollen transport, sugar for genetics. No gratitude required. You can also sense the desert's nightly cooling and what it means for the plants still holding seeds. As air cools, humidity rises slightly, and dew can form again, thin and temporary. A few droplets collect on spines, on hairs, on the edges of dead stems. It is not enough to wake a seed by itself, but it is enough to feed microbes in a crust briefly, enough to soften dust and keep the surface from turning fully hostile for a few hours. This is why deserts can support life that seems impossible, not because they are generous, but because they offer tiny inputs repeatedly, and life is very good at living on tiny inputs if it has enough time. Now, if you let your imagination step backward, you can see the whole cycle as a loop. Rain arrives in a pattern that happens to be usable. Seeds germinate, but not all of them, because the seed bank plays statistics. Plants sprint through growth, bloom, and reproduction. Pollinators surge and then fade. Seeds disperse into cracks, into nests, into shade pockets. Then the surface dries, and the desert returns to its practical colors, and the cycle hides itself again under your feet. It is tempting to call that hiding, but it is more accurate to call it compression. Life compressed into a durable form, waiting for the next brief opening. A seed is a compressed plant. A soil crust is a compressed ecosystem. A desert year is a compressed calendar, with most pages blank on purpose. And because you are a human, you want to make this about you. You want the desert to be a metaphor, a lesson, a comforting story about patience. Fine, take the lesson if it helps you sleep. But remember, the desert's version of patience is not peaceful. It is not soft. It is a truce with reality, renewed every night and broken every morning. The desert teaches you that survival is often boring. Not cinematic, not heroic, not inspiring. Mostly it is small decisions made correctly, over and over, under bad conditions. A waxy cuticle that prevents a tiny leak, stomata opening in the dark when the air is less hungry. A seed coat that refuses to unlock for a weak rain. A fungal thread that reaches one more pore of water than the root could reach alone. The miracles are quiet, and they happen without witnesses. The superbloom is just the rare moment the accounting becomes visible, and eventually, even that visibility is gone. The last petals detach, the last seed pods empty, the last insects drift away or die, finished with their own short season. You are left with a desert that looks, again, like a place where nothing happens. A plain of rock, dust, and restrained vegetation. A landscape that seems indifferent, because it is. But now you know what indifference can contain. A soil library of future color. A crust of ancient organisms that wake with a thin film of water. Roots spread wide and shallow, ready to grab the next brief storm. Fungi waiting in the dark, prepared to trade reach for sugar. It is all still there, arranged for the next time the sky decides to cooperate. And you can let that be the last image you carry. Not the loud bloom, not the crowded hillside of visitors, not the bright proof. Just the quiet return, the plain surface, and the hidden preparations beneath it. Because there is something deeply consistent about a world that does not care. It will not try to entertain you. It will not promise a repeat performance. It will simply keep its mechanisms running, slow and precise, until conditions change. So the desert settles into another long pause, and the seeds settle into their hard, patient sleep. And somewhere far away, a weather system begins forming over an ocean, gathering moisture, deciding nothing in particular. It will drift, it will shift, it will eventually arrive, or it will not. And when it does, the desert will spend again. But for tonight, the ground stays quiet, and the color stays folded away. And you are allowed to do the same, storing your own energy, closing your own doors to the dry parts of the day. Out here, the lesson is simple enough to be almost rude. Rest is not a reward. Rest is a strategy.